Hi everyone, in today's video we will see that how to persist the memory by using the LangGraph built-in persistence layer. We already discussed that how to persist or store the memory by using the file system. So basically LangGraph has built-in persistence layer implemented through checkpointers. When you compile a graph with checkpointer, the checkpointer saves the checkpoint of graph state at every super step. Those checkpoints are saved to a thread which can be accessed after graph execution. In this there are a lot of words that we don't know about, like what are the checkpointers, checkpoint, thread, after that what are the super steps. So let's discuss these things one by one. First of all, what are the threads? A thread is a unique ID, simply. Like thread ID is 1, thread ID may be 2 for user 2, thread ID is 3 for user 3. It is simple as that. After that, there are checkpoints. The state of thread at particular point in time is called a checkpoint. Checkpoint is a snapshot of graph state saved at each super step and is represented by state snapshot object with the following key properties. So just consider it as a snapshot. In our example of Myros, it is a snapshot. In this there are 3 lives, 0 coins and level is 1. And similarly it is another snapshot. In this there are 3 lives, coin is 1 and level is also 1. Snapshot is basically a memory at particular time. At 5 PM maybe the memory will be different, at 6 PM maybe memory will be different. So it varies time to time. After that it has following key properties. It means snapshot has following key properties like config associated with this checkpoint. We'll see what will be included in configuration, and there is metadata associated with this checkpoint, and similarly values, what values will be there, actual values, we'll see this also. And next is basically what is the next node that we have to execute, and similarly task, a tuple of PregelTasks object that contain information about next task to be executed. So what does that mean by PregelTask? LangGraph uses a Pregel execution model from Google PregelGraph parallel computing. Basically it is used for parallel computation that schedule a task to execute the node. For example, create task for node A. We have node A, we have to create the task for that node. Then we have to run the task. After that it will maybe collect output, schedule next task and repeat this process. It is simply a task in the LangGraph. We have discussed the checkpoints. Now let's move towards this picture. Here in this picture there are 2 nodes. It is a graph. The state is I, the node 1, and it is node 2. And after executing the node 2, the state is I heart LangGraph. And these are super steps. Node 1 is super step, node 2 is also super step. Basically it is saying each sequential node is a separate super step while parallel nodes share the same super step. What does that mean? It's mean that suppose we have node A. After executing node A, we have to move to node B and we have to execute node B. Then similarly we have to execute node C. In this, node A is super step, node B is super step, similarly node 3 is also super step. Suppose 2 nodes don't depend on each other. After A runs, both B and C are ready. For example, after executing node A, we'll move to node B and C. In this, A is super step, B and C, these 2 will share this super step. It is the meaning of this line, while parallel nodes share the same super step. Super step is basically one iteration of graph where all ready nodes execute. That's it. And then there are checkpoints. Checkpoints, we know that the snapshots. In this, the state is I heard and the next node is node 2, means it is the snapshot or checkpoint in node 1. After that the state is I heard LangGraph, and the next is end, mean after executing node 2 we have to move towards the end node. And there are threads, node 1 and node 2 both are in same thread. So to get the snapshot at node A, we'll pass thread ID and checkpoint ID. We'll see in a code how to do that. And similarly, to get the snapshot at node 2, we'll pass the thread ID and checkpoint ID also. Now let's try to understand the threads in more detail. A thread is a unique ID or a thread identifier assigned to each checkpoint, means thread is assigned to each checkpoint, saved by a checkpointers. It contains the accumulated state of sequence of runs. So what are the runs basically? A run is an invocation of an assistant. Invocation means we are invoking the assistant or running or executing the assistant. When you execute a run, you specify which assistant to use. And these are the configurations. In configuration, we'll specify what LLMs we have to use, like Claude LLM or GPT's LLM, what tools are attached, and different things. For example, we are saying it is assistant 1, and here we will use GPT-4 and its tone will be formal. And similarly, it is assistant 2, and here we will use Claude and its tone will be casual. And it is thread 1 and user A will use thread 1. Similarly, it is user B and user B will use the thread second thread. These are the runs basically. Here we are saying run A2 plus T1. A2 means assistant 2, T1 mean thread 1. Its mean assistant 2's configuration will be applied on user A. Similarly, we have A1 plus T2, mean assistant 1's configuration will be applied on user B. And run A1 plus T1. We are saying assistant 1's configuration we have to apply it on T1 or user A. And it is saying each run may have its own input, configuration, overrides and metadata. Runs can be stateless, means no thread, or stateful, execute on thread for conversation persistence. Multiple runs can use the same assistant configuration, and similarly the assistant configuration affect how the underlying graph executes. So these are different points. It is the code that is using LangGraph persistence layer, and I think video is getting little bit lengthy. Let's discuss this code in next video. We'll see you guys in next video.